So this tutorial is basically going over the process of moving things from Revit to a 3D printer. And the 3D printer that I'll refer to on a regular basis is what we have here at the Ham School of Architecture, which is a MakerBot Thing-O-Matic. We'll be upgrading to a Rep 2 here very soon, I hope. You'll also hear me call it the Tom, which is obviously short for Thing-O-Matic, which is a great little 3D printer. It's a great intro level 3D printer. It's an extrusion printer, so it's incredibly cheap to use and run, and pretty reliable. All 3D printers break, and all of them require a little bit of finesse, but it's a great product to be diving into and using. So let's look at the process of moving some pieces out. So this is two levels that we're going to do. First, for the project that we're working on to learn prototyping, which is called a synthetic landscape, which is something that picked up from Acadia conference that I attended. Excellent project by those guys. And this is basically a scaled down version of that project where each student is given a zone to work within. So inside of one of these dashed lines, and they have to build a piece to prototype to fit inside of a given synthetic landscape. So they have lights, these overall forms, and essentially then they're going to hand over their file to somebody else to print based off of their 3D model and their construction documentation that they make for the model. So the design, should be responding to the site, the light, and should be something interesting and creative. But I'm going to use these synthetic pieces to go over the first process of pushing something to a 3D printer, and then we'll actually apply this to Project Tony that we've been working on through the semester as well. A piece that would be very difficult to model by hand, the curved roof piece that's bending in multiple directions and has structure following along with it, and looking at a one-to-one type of object to print out to scale. So this first piece right here, this is one-to-one. So these pieces are really small. They're only, 1.5 inches, 2 inches by 1/2 inch to 3/4 inch tall. So these are all really small pieces already. So we'll be printing them, sort of a direct one-to-one kind of thing. So they're pretty easy to work through. So let's just take this little dude right here. It seems like a nice piece to be printing. So the first thing that I need to do is export this. There is a plugin to Revit that will export an STL file, but I'll be honest with you, I've had miserable luck with it. So the process that we're going to use is moving things from Revit to 3D Studio Max to a stereolitho file or a STL file. So the first process or the first step is to isolate that object. So I've got it selected. I'm going to go down here to the little sunglasses, which is temporary hide and isolate. And I'm going to say isolate element. That little dude is completely by itself now. And I definitely want to be in a 3D view because I want to export a 3D object. And I'm going to use the FBX or film box format, the big R, export FBX. And I'm just going to call this base piece number. I'm not sure which number it is. We'll call it 12 in the FBX format. I've got two options. Turn off temporary hide isolate. That's saying, do you really want to export everything or only what I have isolated? And I definitely want to leave temporary hide isolate mode on and export. So that dude is out. I'm going to go ahead and reset that, get everything back on screen. And now I'm going to bounce over to 3D Studio Max. So inside of Max, just kind of zoom out here really quick, the big M, and we're going to go and import. And that was base piece number 12, import, okay. Now I'll see a couple of things. First of all, I know I don't really want the camera. There should be a sun in here someplace too. I'm going to, right here at the bottom right, zoom extents all. There we go, there's the sun. We can go ahead and get rid of that just to eliminate any confusion in the scene. And there is my base piece now inside of 3D Studio Max. So with this piece, again, I know that this is already one-to-one. I'm not trying to print this off as a 16th inch model or something like that. I'm just printing this model off. So all that I'm really using 3ds Max for in this case is to push the STL file out. But we'll look at the importance of 3D Studio Max here in just a second for an architectural model. So I'm going to go to the big M, export, export, and this was called base piece 12. I already have stereolithos selected right here, stereolithography file, STL. I'm going to hit save. I don't have anything selected right here, so make sure selected only is unchecked. I really don't know the difference between the binary and the ASCII2 file, so I've just been sticking with binary and everything's been working well. I typically don't change the object name. That's not your file name. That's the name of the object inside of the file. As long as I don't have anything too complicated going on, I just leave that as whatever the default is and say, okay. So our interface with the TOM is RepG. We're currently using version 34, which is a dated version, but we have it working well. So why upgrade what's working is kind of our thinking. So I'm going to go File, Open, Base Piece 12. Now, if you'll notice, this is currently not hooked to our TOM. This is off of my laptop, which isn't hooked to the TOM right now. So the connection error, when you're working on our machine connected to the Thing-O-Matic, you're not going to see this. This should be green. So I've imported this, and as you might note, there's actually nothing showing up right now. There are two reasons for that. First is, if I switch back to 3D Studio Max, that piece is in a pretty arbitrary position. So there's 0, 0, 0 on my grid, and my piece is sort of way over here. And that's largely because Revit really doesn't care too much about where 0, 0 is. You know, it's pretty far off center, but that's easy to resolve inside of RepG. I'm going to do two quick things. Under Move, I'm going to say Center, and then the next thing is I definitely need to put on Platform. Again, with an extrusion printer, gravity works. So as it's extruding the plastic, if you do not have it sitting firmly and squarely on the base, you will end up with a great big pile of spaghetti. So you definitely want to make sure it's on the platform. Next thing you'll notice, it is way too small. So I'm going to go back to my view mode so we can kind of zoom in on this here. So you can see it's this itty bitty dot. And what we're dealing with on that is there is a scale conversion factor moving from 3ds Max to Replicator. So the base unit in the programming in RepG is a centimeter. I believe it's a centimeter. Let's check that really quick. Oh, it's a millimeter. The base unit in 3ds Max, 1 equals 1 inch, RepG 1 equals 1 millimeter. So essentially we need to upscale this. This is roughly about a 4-inch by 4-inch cube. That piece should be about 2/3 of the size of the cube. So if I use my upscale conversion inches to millimeters, you can see it's not quite 2/3, but I'm going to trust that that's just about accurate. That looks like it'd be about a 2-inch piece. Let's go into Revit. We'll double check the measurement of that guy. Level 1 plan, I believe. Let's see which piece that was again. View, it's that guy. To Revit, I believe that is this guy right here. Let's do our quick measurement across. Yeah, that's only about 1.5 inches in size. So that's, you know, knowing that that's 4 inches, that looks just about right to scale. So I'm pretty confident that that is ready to send to the printer. So the printing process is really simple since I'm not hooked to it. I'm not going to run through it just yet on this computer. That'll be a second video. But essentially I'm just going to hit Generate G code. And you'll want to work with us on the default settings for your piece. Each object's a little bit different, and it's going to vary based on the plastic that we have in place, those types of things. But it's pretty much as simple as running the G code and then hitting print. But let's look at the process again with an actual architectural model, something that's not at a 1-to-1 scale, because things get a little bit more complicated and we definitely have to rely on 3ds Max for a scale factor. So let's switch over to project toning here. So here's our 3D view. And in particular, it's this roof piece. This is bending in multiple directions. And in terms of model materials, you know, maybe we could cast this with something. Maybe we could paper mache it. Maybe we could run it through like a CNC router and get the form from a subtraction process. We could whittle it out of a piece of oak. But this is where 3D printing for a scale model comes in really, really handy, because this is exactly the type of thing that works great for a 3D printer. The problem is that we have an extrusion printer. So we can't just sort of build this arbitrarily. We need a simple edge to be able to build up off of. and keep gravity working. So what I'm going to do is I'm going to isolate the roof, and I'm going to section the roof into 2 pieces, and we'll actually print it in 2 parts, sort of growing the roof up off of an edge. So what I'm going to do is first thing I'm going to cut a section. Let's go to level 1. I'm going to zip a section pretty much right through the center of this roof piece, just like that. And I'm going to use that section as a baseline, printing one side of the roof and printing the other side. So I have a really good flat edge to begin the roof extrusion print off of. So I'm going to go to my 3D view, and I'm going to use the view cube with a right click, orient to a view, section 1. Okay, so that's the edge that I can start printing off of. That's a really good flat edge. The roof isn't doing anything ridiculous in terms of curving in or out. You know, we can print at about a 45-degree angle up off of the printer. Now, extrusion printing isn't quite there yet. You know, you're not just going to hit print and send an entire building. There are printers that do that. You know, for the architecture profession, they're pretty close to unaffordable right now. This, you know, sending something like this might be a $400 or $500 print, whereas in an extrusion printer, it's, you know, maybe 10 cents. So I'm more interested in parts that we can experiment and work with, where if we mess one up or we just want to experiment with multiple pieces, try multiple variations, and introduce an iterative process. Not just print something final. An extrusion printer is perfect for this. We just have to sort of work through the complexities of gravity, you know, to make them work. So essentially I'm going to hide a few things in view. You know, and those structure, I mean, that structure that I just hid, that's, you know, 10 seconds with a laser cutter. There's really no reason in my mind to try and send those through a 3D printer anyway. I'm going to hide the curtain wall again. Sort of, I feel the same way about that. You know, that's a perfect laser cutter task. So this is pretty much ready. Again, I feel really confident all these beams are going to work great, except for, you know, and I'm thinking about, again, printing this side and growing it from this out. So I'm essentially going to stand this edge up. But now, again, if I send a line of plastic suspended in air for this beam right here, I know that piece is going to fail. So I know I'm going to have to send that as a separate element as well. So I'm going to go hide in view element right there and get that. And that is ready to print. And it's going to print all of that out as one nice piece, except for this little dude right here, Laron. Let's hide Laron really quick too. Hide in view element. So that guy is ready to export. So what I'm going to do is I'm going to go ahead and run the export process as an FBX. Big R, export, FBX. So let's call this Tony Roof 1. I should probably be calling it Tony Roof East or West, but I'll be honest, I don't remember which one's which. So I've got half of the roof exported. I'm going to do the exact same thing with the other half. So I'm going to collapse this side of the section cube. I'm going to expand the other side of the section cube. Probably have to hide a few things again. Hide in view element, hide in view element, and this beam again. Hide in view element. Okay, so I have that piece of the roof completely ready to go. So let's take that, big R, export, FBX, Tony Roof 2. Save. So essentially I've got 2 pieces. I would probably be printing them one at a time, not both together. Don't trust 3D printing quite well enough to risk running both of them if one piece starts to fail, but feel pretty confident both of those will print just fine. I would just prefer to do one, print one, then the other. And then essentially you'll be gluing and sanding that joint back together. So let's move those into 3D Studio Max. So Big M, import, Tony Roof 1, and I'm only going to walk through one side on this guy. So there's my roof. Again, I'm going to go ahead and kill the camera and the sun. I just want to get left with just this piece of the roof and structure. So you can see, again, I've got a really good flat edge that I'm going to be able to print this off of. I'm going to select everybody. So that was just a great big lasso around everything. And I'm going to group them, make it a lot easier to scale this. So one of the things Revit doesn't do, Revit basically says, I will scale when I print. That is your option. And what I want to be able to do is I want to take something like this and scale it at the point of exporting the STL file. So I need to scale it right now before I export it as the STL file. So again, this is a 1-to-1 file right now. If I measure across this, I know that this guy is about, well, let's just check really quick. Back into Revit. Let's go to our site view, the ruler. So that's about 53 and a half feet across. And at a 16th inch scale, let's see here, I have that, I believe, in a sheet here. If I look at that view in a 16th inch sheet, it's the easiest way for me to do it. I know that piece is going to be about 6 inches if I'm printing at an 1/8. And I know the Thing-O-Matic has about a 4-inch by 4-inch base plate. So 16th isn't going to be, or an 1/8 inch isn't going to be so good for me. So let's think about this at a 16th inch scale. Let's go back to the sheet here so I can do another quick measurement. Yeah, that roof piece now is right about 3 inches, 3.5 inches. So now that's going to fit really nicely on the Thing-O-Matic base plate. So let's go back into 3D Studio Max. I've got everything grouped. And now what I need to do is I need to apply a scale factor to drop this down so that it prints at a 16th of an inch. So I could go to my uniform scale right here. And I could just sort of eyeball it, move it up and down until I think it's about right. But that would be pretty much a disaster. So there is some math that we can do behind this. And to keep it easy, on the digital design website, the Architect's digital design website right here, if you will go to Revit to Real, you'll see a chart with all of the basic scales and then an explanation on how to do the mathematics right here. And trust me, if I can do the mathematics, it's pretty easy to follow. But for the basic scales, I have some things pre-listed on here. So if I want a 16th inch model, I know I need to decrease the scale by 0.521%. Okay, so I've got this roof piece in now, and I'm going to go ahead and drop the scale by 0.521%. Now I'm going to go Zoom Extents, and you can see that roof has now significantly been shrunk down. So I'm ready to go ahead and export this guy as an STL file. So big M, export, export. So call this Tony Roof 1. STL, save. Yes, I do want to go ahead and replace it. And OK. Oh, we need to select everybody first. My checkboxes were checked. So got everybody selected. Export, export. Tony Roof 1.stl. Yes, I want to replace it. Selected only. That was selected this time. I want to make sure that that's working correctly. And OK. So now in Replicator G, file open. Tony Roof 1. So the first step that I need to do is move it, center, put on platform, and you can actually see it's really bitty small right there because we still need to move it through the scale conversion factor, inches to millimeters. So we can see that that's just about right now. So I've got it at the right scale, but I need to put this edge on the platform. Otherwise, again, what's going to happen is just a great big pile of plastic. So really easy to work through. So I'm going to go rotate this time, and we're going to rotate it up in the -X direction. And what I'm looking for is this edge where those beams start, not where they finish. I want those beams to start on the platform. So I need to rotate it about the x-axis 2 more times. Then I'm going to use the lay flat function. So now if I back up and we view this, you can see that flat edge, but now I need to put that flat edge back on the platform. So move, center, put on platform, view. And now you can see I've got that nice flat edge, and that is completely ready to build on the MakerBot. And it should build that wall and that structure together really, really nicely. So again, the process is the exact same. I would go ahead and send that out using generate G code and then build. And then I would swap, do the exact same thing with the opposite side, and I would have those 2 pieces ready to go.